introduce Marcel, who's a very important person for those of you who haven't yet realized this. Marcel is an editor, along with Evelyn Forget, of the Journal of the History of Economic Thought. And I mention that because there are some, quite a few graduate students and undergraduates here who might want to see what you can find out about the world of publishing from Marcel. So that's one point that I just wanted you to know, because sometimes young scholars don't necessarily know who's editing what or which face goes with what name and so on. So we're going to learn today about history of economics as a history of tools and techniques. So it's nice to have Marcel here from the University of Amsterdam.
Just mentioning the jihad, I just want to announce, especially for the people who are just almost finishing their PhD or have finished their thesis. What's new in the journal is that we, one issue here, the December issue, could have separate pages for abstracts. So it doesn't matter whether your thesis is written in another language, but the abstract, of course, has to be in English. And so you can tell the world what you have done in the past few years, so people get interested and maybe contact with you. So that's something new, and I invite all of you, if you have not already done so, to submit an abstract of your thesis when it is finished. Okay, that's done. Now to other business, the talk of my day. This is unusual for me, because it's the first time ever I present a paper which is not finished. Wow, yes, so I'm nervous about it. But I know of the Summer Institute that I get the opportunity to present on major ideas. So I take this opportunity. The reason is that
Just to interrupt briefly, when I first presented at the Summer Institute, David Levy told me that this is a place where you can say stupid things at zero cost.
Yeah, I'm not sure today. About that. Okay.
We have to change that.
So, what's the project and what is the thing I'm writing about? It has to do with two things. One is that just 2 months ago, when the BP started to have their problems, I had a HOPE conference, the Journal of HOPE, on the history of econometrics. So that is one part, and if you added such a volume, we have also to think about introduction. So this is a paper about historiography of writing a history of econometrics and a history of mathematical economics. The history of mathematical economics is also something not so many people really work on. The well-known examples, of course, is Roy Weintraub. There's another guy in Brazil, Pedro Duarte, but there are not so many. And so, talking with Pedro, we try to encourage also that people can write more about the history of mathematical economics. The HOPE conference was to encourage people to write on the history of econometrics. But so the thing is that something different than writing the history of economics. That's the larger project I'm involved with. Just to let's start to give a picture, and we do that by giving quotes. This is Irving Fisher in his thesis, the last section of his thesis. Almost at the end of the 19th century, and says the following: the effort of the economist is to picture the interplay of economic elements. The more clearly cut these elements appear in his visions, the better. The more elements he can grasp and follow in mind at once, the better. The economic world is a misty region. The first explorers used unaided vision. Mathematics is the lantern for which what before was dimly visible now looms up in firm, bold outlines, etc. So we see better, we see also further. So mathematics is the tool to see better, and we need it. That is, of course, his thesis about what he gives it. People know this. It's a very long bibliography about all the people who work at that moment on economics. Okay, should we make a jump just to say, okay, that's Fisher in the 19th century. This is the starting point of what I see this as the starting point of modern economics. And then Robert Lucas, who has in his paper, it's not in the book, but in a paper called Method and Problems of Business Cycle, he is provocative, as he always is, and he said there's only two developments in economics, and they arrive from two different kinds of sources, forces outside economics. One is technological development. The second one, so that means improvement in mathematical methods and in computational capacity. The second one is, of course, the different. We change our questions. But just look at the first one. So he is, and there's another quote from the same article. That is, this is already the program Prescott and Kitland are carrying on. That is exactly what they are going to do. They call it computational experiment. But that's the series is not a collection of assertions. No, it is a set of instructions to build a model. Was a good model, a good imitation. And how do we do our task? We write a Fortran program. We write a computer program. You see, that is the task of an economist. There is another quote in a small booklet of him called "Aren't we all technicians?" So something like that. So so there is something in economics. I'm not saying that this is the overall, but there is something that it's worthwhile to look if the developments come from new techniques, if the developments come from mechanization, if the development comes from computational capacities and developments. So we, as historians, have to think about how to write that history, because, or maybe it is different than thinking about the history of economic thought. And that is exactly what I would like to investigate. A starting point of thinking about this is a good colleague of mine, Mary Morgan, who wrote a chapter in, this is a multi-volume project of Cambridge University Press, this the history of science. So all the sciences, the histories of all the sciences somehow got covered in, I don't know how many volumes it are, 6, 7 volumes, really interesting. And she wrote the entry on the history of economics. And so what she does is economics in the 20th century. And what she calls it is, the way she sees it, is that it is very much, the best way to describe this development of economics in the 20th century is very much as economics as engineering. And just take this, the last part, I'm not going to read it obviously, but this part is, the engineering metaphors also suggest that 20th century economics is best characterized as a science of applications and applies to technical art. So the second one is, this is also from that chapter, in which she describes the development effect, and that is of course her main work, is on the history of modeling. That's also part of my work. The modeling practice is what I call the new 20th century practice, which you wouldn't find in the 19th century. So that's something new is coming up in the 20th century in economics as a science and as the practice of modeling. And so that's, and what you see is that it's very close related to the rise of mathematical economics and the rise of econometrics. Both are also 20th century developments. You see, that's the history we tried to write. So I hope that Okay, so how to write this history? How to write history of mathematical economics and how to write history. And of course, these are very closely interconnected. So therefore, you will find in the work of, for example, Mary Morgan, but also my work, a lot of work on the history of both subdisciplines or whatever you call it. Okay, I already mentioned Roy Weintraub, who wrote a very nice book, How Economics Became a Mathematical Science. And so he's also thinking about how to write its history. So in this last chapter of the book, he is also a chapter on historiography, thinking about how to write this history. Maybe we have to do it another way than we did before. And he comes up with Leo Corey, and he's interesting because I haven't dated it, but the paper is somewhere in the 1980s, so it's an old paper. But the nice thing about the paper is that Corey makes a distinction between the body of knowledge and the image of knowledge. And he calls the questions related to the body of knowledge, he calls this the first order questions. So these are questions about subject matter. So the usual questions economists ask about development within the economy, what's going on, can we explain this, etc. These are the first order questions. But you have also, within a discipline, second order questions. They are much more related to what Corey calls the image of knowledge. That is about the discipline, qua discipline. They concern methodology, philosophy, history, sociology, etc. Mainly the questions we have addressed here the last few days and probably also going to raise tomorrow. These kind of questions, they evolve history, they evolve the methodology of the discipline. But interesting, and that is why I come now, is that according to Corey, they are addressed by ancillary disciplines, but there's one exception in his, because he's much more involved with the history of mathematics, and he said mathematics is the exception. Mathematicians ask these questions within the discipline itself, they treat them within. And this is why I tend to disagree. Looking at the history of econometrics, and I'm going to show you that, I have evidence for that, and looking at the history of mathematical economics, you see that these questions, second order questions, are part of the disciplines of econometrics and mathematical economics. So just to be clear, what's body of knowledge? These are the theories, facts, methods, and problems. Just think about, if you see that you can think about the Kuhnian idea of the paradigm, or what he calls normal science. Yes, that's just. The other one, these images, so this, they rise from the body of so you started this summer institute that you have questions, and for some of the first order questions, sometimes can be better answered from an historical perspective, and this is what you see then that turned into a second order type of question. What are these? These are some. He has more examples, but these are nice. So second order question: which of the problems more urgently demands attention? They cannot be solved by the body of knowledge itself, according to Corey. These are just outside second order problems. How should we decide between competing models? So that's referred to methodology. What procedures individuals, institutions have authority to adjudicate disagreements. So to Corey, these are not really addressed by the discipline itself, but other disciplines like philosophy, like history, but in mathematics, some of these questions are dealt with by mathematics itself, but I'm just going to show that part of this part of the story if you look at econometrics and economics. To give you, I think that's a very clear example for it. Look at this. This is Ragnar Frisch. This is his first paper ever published by Ragnar Frisch in the field of economics. However, it was published in a Norwegian journal, written in French, so people didn't know this one. It only became much later in the 1950s, translated by Jepson and published in English. So this is the English version. So the thing I write down is from the translation by Jepson. This is the article. It's the first paper written by Ragnar Frisch, in which he coined the term econometrics. And so that's interesting. And so he gives a definition. Not really this one definition, but he gives a description of what he meant by it. Intermediate between mathematics, statistics, and economics, we find a new discipline. That is not true. The discipline doesn't really exist, but somehow that's what you hope for, wishful thinking. We find a new discipline which, for the lack of a better name, may be called econometrics. Okay, but interesting is also because that has to do with this first and second order question. Immediately, he also has this part. Econometrics has as its aim to subject abstract laws of theoretical, political, or pure economics to experimental and numerical verification, and thus to turn pure economics as far as possible into a science in the strict sense of the word. So going with thinking about a new discipline, it is always also thinking about how to turn economics into a science, because in his view economics was not yet a science. And he was not alone. When you see the first founders of the Econometric Society, people like, know more about, is like Jan Tinberg always had expressed this aim: we have to turn economics into a science. And so that raises the questions about what is science, what do we mean by it, and then there's a lot of discussion about what I mean by science. And it has, of course, to do with this unification of mathematics, statistics, and economics, which is very close to what we today call the logical positivist program in the 1920s and 1930s. So that was in the air. They were part of that. Okay, so that's, so you see from the beginning, this question about science, this methodological question is being addressed. Goes with the new discipline. Okay, so one of the problems I had with thinking about the history of econometrics is if we're running this whole volume, is thinking, what is econometrics? Okay, to start, when I started, I just used Frisch's definition, the unification of mathematics, statistics, and economics. But that is not econometrics of today. Econometrics is not like that anymore. That's changed. And the reason, of course, to change, but it is different. So writing a history of a field is struggling with the boundaries of the field. And so therefore, so what do they mean by it? And this question cannot be separated by thinking about historical and philosophical questions, or that second order questions related to himself. And who are the people who go on and solve this problem, the second order problem? Interesting is that these questions, the second order questions, when you look at econometrics, now I'm mainly talking about econometrics, is that from the beginning, like Frisch, are addressed, also the historical questions are addressed by econometrician himself. Evidence is this. I skipped this, just a summary. This is what I am doing here is what I show you. Econometrica, that's a new journal of the society, which is the new discipline. The first issue already has articles on what they call the forerunners. So in trying to define the boundaries of the field or to get an understanding of what is the whole project, they starting doing history, which is quite unusual for an econometric journal, I can say. And so these are just what you see in italics. These are the forerunners, and then you see people who contributed, wrote articles about it. You see that's just so maybe you recognize some of them, but but also about the founding fathers. Which are the founding fathers? That are people like Frisch, Tinbergen, but other people they considered. And you see that it's because there's some kind of celebration anniversary, because of death or whatever reason, obituary. You see that in Econometrica you have these articles. Yes.
How should I read it? So Henry Schultz is considered to be a founding father by Hopeling and Douglas?
Yes. And that also means by Ragnar Frisch.
Okay.
Because he's the editor and he decides everything.
Right.
He's almost like one.
And they stopped having fathers in 83?
No, the fact that they stopped earlier, and this is an exception, they stopped halfway in the 1960s, surprisingly. Then it is over. That's your indication in one exception. But if you look at just at the dates, then it starts. So even, just to set the scene quite clearly, even when Ragnar Frisch and Jan Tinbergen, two founding fathers of econometrics, got the Nobel Prize in 1969, there's nothing about it in econometrics. To make this clear. You could use that, but they didn't do that. Well, history was out. I don't know why this is so the exception I had to, but then that if you look at the generals, that it just dropped, figures dropped. So to go back, so from its beginning, this is what I said. You have this is what I said. The Nobel Prize is not there, so that's. But interesting, and that is the second part. In the 1980s. You get a new journal, Econometric Theory. It has one editor since then, it's still the editor, Peter Phillips. And he has some aims with the journal. So the first issue of that journal, he writes an editorial in which he clarifies his editorial aims. And these are interesting, because these are this, 0.5. The other ones of course very much about other things, but editorial 0.5 is to publish historical studies on the evolution of econometric thought and on the subject's early scholars. And just you don't need to read everything. There's a passage which is starting here. Many of us, that is like you started this summer today. On Sunday. Many of us have much to learn from these historical traditions and from the talents, concerns and achievements of these forerunners who present-day econometrics. Happily, this field of research in the history of thought is now under development. In support of this field, ET wishes to encourage the publications of articles that explore the nature of this historical tradition, examine the evolution of economic thought from its foundations, research, and study the subjects in early scholarship to enhance, to advance econometrics. History. We need history. Wow. The second is that is very interesting because this is the beginning of oral history in econometrics. So the next point is to have interviews with these econometricians. Sometimes you had to be quick because they were old and some people were just in time to have them interviewed. So what I'm saying here, this is an econometrician. Peter Phillips, an econometrician, running his new journal and said we need history. Oral history and just about the tradition. Econometrica started with history. So they considered history as a part of it. What you see is that the main claim is the history of econometrics is mainly written by econometricians. Just take the first example, Carl Christ. He is Coase Commission, and he wrote about the history of Coase Commission. If people today would talk about econometrics, the image of econometrics, what they very often mean is Coase Commission econometrics. That's the version you find in your textbooks. And that is intentionally. This is built up by someone like Chris. Then you see just these three major works in the history of econometrics. Who are they? Roy Epstein. He is out the field. He is now a consultancy bureau. But he was a student of Peter Phillips. Wrote this nice book, A History of Econometrics. Quite useful if you want to have an understanding of Coase Commission econometrics. You get it from that. David Hendry, and I come back to this, there was a reason for David Hendry to be interested. The 1980s, and I come back to that, you have these debates within econometrics about what's the right methodology. Yes? And so he got interested in history. He saw something of Half-a-Mole. He did it before. He got from someone else all the old econometric guys, starting reading them, starting to read Half-a-Mole, and said, hey, wow, that's great. And it is great, I can tell you. I very much love Half-a-Mole's work. It's great. It is about methodology. Most people know the second part of his probability approach. That is this testing Newman and Pearson. But you read the first part of Half-a-Mole. That's methodology. Quite interesting. So he got married by accident. Married, he just wanted to leave the banking system and asked for employment. That's the story she's telling. You have to be suspicious about this kind of story. But she dropped into Henry's room and said, do you have something to do for me? And I said, yes, you study this. Start studying this material. So that's his PhD. Mary is on the history of econometrics, which became the well-known Cambridge for him. Joaquin was in China translating Klein, Lawrence Klein, and because that has also to do with the development in China, wanted to go to the West. And so how do I get some understanding of econometrics? And Henry said, just start doing history. She got her involved in that project. So you have here three major books written. They're written in the 1980s. This is a mock when the debates are going on. Of course, the publication date is a little bit later, but you have to be aware that stuff being done in the 1980s. History. Okay, so this is so I already referred to methodological debate. So we need historians for several reasons, but in the 1980s, where you get a rise in interest in the history of econometrics, is methodology. But look at methodology itself. Methodology is always being part, as I showed you, of econometrics. Just look at the famous debates. You have probably seen them. The first is the measurement without theory debate. You all have seen this somewhere. This is the discussion between. It is about empirical research. How should you do empirical research? That is the discussion between the Coase Commission, represented by Koopmans, and Vining, representing the MBER. Koopmans, in his essays on the state of economic science, wow, that is an econometrician with a background in physics, wrote mainly about statistics, and he's going to tell what the state of economic science. It's not only talking about econometrics, it's talking about economics. It's very interesting piece of, it's 3 essays, very interesting to read. There's a lot of, I'm still working on it, but there's a lot of interesting things about for this project. So these are the well-known things. This is already the debate I referred to, where you have econometrics is in a crisis, what to do, what is the best way to go. The Coates Commission kind of econometrics somehow was losing ground, and so it's all alternatives, but which is the best alternative? You have Henry, of course, did what is being called the LSE approach. You have a Bayesian approach, Lima. I also would like to include Zelman. And you have the farm approach, but more today, current is, of course, there's much more a hidden debate, but the debate is really going on, is what's the best way to get your empirics to your model, to bring it an estimation, it's a calibration. This is also a very nice debate because it goes across, of course, about method, but also methodology. And also, a few of these debates is also really about economics as a science. How should it look like? Okay, so that's the, okay. So that's how to write this history. There is a good example. There is a very good example who did write the history of mathematics, which I very much like. It is a booklet called Proofs and Refutations, and it is written by Lakatos. And so let's have a look at this. This is a very nice quote. He has this quote both in Proofs and Refutations, but he has also this, and this is the article I'm not going to discuss, is thinking about rational reconstruction. This is the way to write history. Just this idea of rational reconstruction. That is, we have to discuss a lot about that. So, but this is good. That can't somehow twist it. Philosophy is science without history of science is empty. History of science without philosophy is science is blind. So it's never. If you read Proofs and Refutations, it's interesting. This is his thesis, so it's a very early work, but only published after his death. So that's. Yeah, so it is it's 3 histories it's containing, and the main text is that rational reconstructions, which I'm going to tell you more about later on. In the footnotes, which belong to the main text, they have a really important role. That is why you find the history, as we would call it, history. So it's very, very nicely done. By the way, if you look at Marius Morgan's History of Econometrics, she does something similar. She has struggled with the material. So how to write this history? And then she got the idea to do it like Lakatos, the rational reconstruction is done by a classroom debate. Alpha, beta, gamma. Students, teachers are discussing. That's the way the history is being told. Mary, in her book, is struggling with the history, and she put it in the form of letters people writing to each other. Not real letters, but just to tell the history. So that is a longer tradition. My background is in mathematics, history, and philosophy of mathematics. And this is what's already been done in intuition. Yeah, no, how does the mathematical, I just grasp it with the English. Brouwer's
Intuitionist?
Yeah, probably. Can someone help you? What's the English term for Brouwer's philosophy? Okay, that's one. This is new. That's new mathematics, beginning of the 20th century. That's topology, very hard to grasp. it's hard to be formalized. How to bring these ideas to the larger mathematical audience? They have this classroom construction. Classroom which so there's a longer tradition in mathematics of that that I think that is where he got it from. Where you have a classroom situation in which somehow the argumentation across the years is being reconstructed in arguments. So just but it's interesting. You see how you have to struggle with this history. Okay, what's rational reconstruction? That is what it is. So what he says, so historiography should be learned from the philosophy of science and vice versa. We need this interaction. So philosophy of science provides normative methodologies in terms of which the historian reconstructs internal history and thereby provides a rational explanation of the growth of objective knowledge. B, two competing methodologies can be evaluated with the help of normatively interpreted history. C, any rational reconstruction of history needs to be supplemented, people forget this C part, by empirical, social, psychological, external history. Most people forget about this. That's rational, but this C is also there, so don't forget. Okay, what is the difficulty we have with Architects? Just think about Rory Weintraub writing about this, because that is the way he wrote his history of general equilibrium theory. That is a reconstruction a la Lakatos. Yes?
What is external history? Is it contextualization?
External history is what it says, developments in society,
Right.
which or psychological development, which has to be part of it. So Roy, starting writing his history of general equilibrium, it's a very nice example of it in economics. Very nicely done. But later on, he didn't like it anymore. He distanced himself from it. What is the reason he was not alone? What is the main reason people distance from this is this normativity. As if there is one good way of looking at science, forgetting that philosophy of science is also part of an historical development. And so the other critique he has is that we take too much distance from practice. I'm not sure whether that is true, but in philosophy of science we are moving to what we call the naturalistic turn. That means we go off from this normative stance and looking more what practitioners, scientists are really doing and try to understand what they are doing. Then taking this ivory tower position of a philosopher and knows how the world should be and telling people, scientists, how they should run their business. That's long ago, that's his past. But still, Lakatos is interesting. So what I now show you is a revision of it. I think it is an attempt, so you can shoot on it, but it's an attempt to take account of current ideas and insights in philosophy, both in philosophy and history of science. And this is the revision.
Is this yours?
This is mine. The changes is in red and crossed through. So the black, so you can see what I've done, I hope. So a normative methodology is historically contextualized. So that is what we know. So you cannot have this overall position, this arbitrary position. No, we have to know that history, thinking about science has changed across a century and still changing. So, but a history of these changing visions, a history of philosophy and science, provides, like any history of economic theory, gives us insight about alternatives, provides the developments of methodology, forget about normative, just development of methodology in terms of which the historian reconstructs the internal history, the history of the discipline's body. Part of why I'm making this change is thinking about, if you look at the history of econometrics, if you look at the history of mathematical economics, it is about changing visions about what science is all about. If Frisch was aiming at to turn economics into science in this very early work, that article I showed you, that meant axiomatization. He only wrote one paper on axiomatization when it comes to econometrics, and that is that paper. And this, of course, has to do with the Hilbert program. That has to do with what people thought at that time, in the 1920s, what science should all be all about, that is axiomatization. But if Coleman talks about the state of economic knowledge, it has changed. Different views. So we have to take account of that to understand its history. Okay, the debate between two competing methodologies can be evaluated with the help of the history of the discipline's image. So we have to look at the changing methodologies. We have to look at this history. History and philosophy going together, that gives us insight how debates are somehow settled. And C, any history needs to be supplemented by, so that's all it didn't change, only this rational reconstruction, but that's, so you see what I try to do. So, understanding the boundaries of these tools and technique-driven disciplines cannot be done with the history of philosophy of science, the history of changing methodologies. That is. How much time do I think we start at 22. Can I talk a little bit, just to give you an example of this? Not about the history of econometrics, because I'm still working on it. Not on mathematical economics, I'm still working on it. But things I already have done. The history of economic modeling, which I already called. And I show you how this interaction between philosophy and science, changing the history of philosophy and science, and that new practice is helpful to understand that history. That is what I now try to do as an example of such a history. Okay. Just take the history of modeling. When does it start? According to me, it starts here. The word wasn't really used. It was not really used in a very specific way as we use it today. The first time you can find the way model being used is Jan Timmer. He wrote in a German journal, Quantitative Frage der Konjunkturpolitik. He talked about the subject, quantitative questions about business cycles. And the funny thing is, in the article itself, you don't find the term model. But what was normal in those days is you have an international journal, and it was supposed to be an international journal. Think about the dates and what had happened in Germany, but still the aim was is you have abstracts in different languages, English and French, of course. Maybe also Spanish abstract, I'm not sure, but that's so just. And then in the English one, he used the term model. What did he mean by it? This is interesting. The presentation of a simplified business cycle mechanism. So mechanism somehow connected to the idea of modeling. You model and presentation. Today we would call it a representation. You have a representation of a mechanism. Keep that in mind. It has to do with policy. Models are always, I would say, always built for a certain purpose. That distinguishes them from series. Series has to do about assertions about the world. Some people call it the truth about the world, but assertions, let's call them assertions. Models are always built for a specific question, have always a purpose. You have a question, you build a model. You see that here. His interest, of Tinberg's interest, was policy. We want to, we are in an economic crisis, so how we can avoid future crisis and how we can get out of this one. That's it. And so there's practical reasons. That's also what goes with it. Okay, where does it come from? A new idea, model, having these characteristics, where does it come from? Not out of the blue air. It has to do with his background. His background is in physics. This is his supervisor, Paul Ehrenfest. Paul Ehrenfest, his supervisor was Ludwig Boltzmann. Ludwig Boltzmann, for those, is the one of statistical mechanics. Boltzmann was very much in favor of Maxwell. Why? I can explain you that. So he took a lot of the methodology from Maxwell. Right? But Maxwell was quite influential also on Hertz. I'm going to explain you, and that is not right. To Gibbs. And Gibbs is to be probably better known because Samuelson quotes mathematics is a language. Quotes Gibbs, and so you can see where. Okay, so so what is this kind of background? What is this kind of history or philosophy of science lying beyond Tinberg's introduction of models? We have to start with Maxwell. Maxwell is very clever. That's new. There's a new method in physics. You see, modern science starts with Maxwell. Modern physics starts with Maxwell. He introduced the idea of analogy. If we don't understand a specific field, we can use the knowledge of a more familiar field to get an understanding of that field. That's an analogy. What's the analogy here for him and in those days? This is about mathematization of physics. So that's the period. If you look at certain behavior, physical, natural behavior, that is described by mathematical equations, and sometimes you have totally different kind of phenomena can still be described by the same kind of mathematical tools. Just think about second order differential equations. What do they give? They give these wave movements. There's a lot of phenomena in physics you can describe by second differential equation, second order differential equation. That is what he used. He made this distinction between, anyhow, this is later taken also on by philosophers, but it is about mathematical phenomenology. You look at, you have a mathematical description, and maybe you can use it for another field which you don't know yet. You are still investigating. That is how he got to his well-known theory, electromagnetic theory, which starting point for 20th century physics. So that's so. Hertz liked it very much. He wanted to change physics. He was thinking about how we have to think about physics in a new way, and what he did introduce, and this became quite influential to the logical positivist by Ludwig Wittgenstein. Enormous influence, because he introduced something. He introduced the idea of Bild, image. Today we would call it a representation. That is how that's the container of knowledge. But be clear, this is something new. It's an image, a representation. We're not selling. Let's not talk in terms of truth or whatever. No, we have it. Built, and that's all we can get. And got this from this analogy idea of Maxwell. the relation of a dynamical model to the system of which it is regarded as the model is precisely the same as the relation of the images which our mind forms of the things themselves. That's the analogy idea. That's how we get an understanding. I get an understanding of this. I don't understand how it works, but I understand this. I have a picture of this, and I'm going to use this understanding to use this understanding. He didn't, of course, this in the translation. This model were not used in the same way. Model meant a physical model, a three-dimensional model. So he used the term build image, but today when we talk about model, we mean build. Right? This is going too fast. Interesting. Okay, we have a representation of something, but of course I can use any representation. I can use any build, but I have to make. I want to get knowledge, so I have to introduce certain requirements I need for that to choose among the builds I can have. How do I proceed? This is his suggestion. First, he said logical permissible. This is his translated words. That means just think about rigor, about logical consistency, etc. The second is correctness. If I have relations in the world, my model must correspond to that relation. So the mathematical equations should correspond with the assumed relations in the world. That's correctness. I think that's quite familiar to you. The third is maybe less familiar. It's what he called appropriateness. That every model, I didn't emphasize that in Timber's first, what I showed you, every model is always a simplification. Think of any economic system, it's always too complex. So if we build a model, it's always we have to simplify. The problem is, of course, how to simplify. That is what appropriateness tells you. He's very explicit. This is the hardest part. Because that is the art of science. That's the art of empirical research. You find those elements out of the world, which is you call essential. But how do you know if something is essential? Yeah. Okay, that's the business. What's the history? So he is a physicist setting out some philosophy, a methodology to get knowledge. He is concerned with physics, but that became somehow a broader application. So Boltzmann, just to show where I'm going. Maxwell, Hertz, we now have Boltzmann. We just take this through. Okay. Boltzmann. That's it, just read, I read it out, just think about it. So the final decision as to whether the pictures of build-up are appropriate lies appropriate. He's not talking about pessimism, that's what I mean. Correctness, no, he's talking about appropriateness. Lies in the circumstance that they represent experience simply and appropriately throughout, so that this in turn provides precisely the test for the correctness of those laws. Laws are chosen, physical laws are chosen by their appropriateness, not by their correctness, not by their logical consistency. He needed that. He was developing statistical mechanics. He used the concept of atoms. But in that time we didn't know whether they exist. They were just a concept, an ancient concept, but it is only with Einstein's Brownian motion article is a tool to make atoms visible. Today we have the technology. So he was working with a concept which he wasn't sure whether it existed. And so he used this appropriateness was what he needed. He needed this idea of build, representation, not about an ontological claim about the world, not only an epistemological, methodological claim about the world. You see? So that's his appropriateness. And that goes, I come back to that goes to Ehrenfest Tinbergen, but the other branch, sorry.
That's not your translation, someone else translated.
Yeah, that's not mine. No, that is.
So is it a noun appropriate and an adjective and adverb appropriate and appropriately?
Yeah.
Those are correct translations.
Maybe I did something wrong, but
it says it's appropriate because it's appropriately used or something.
there's something missing in me. Okay, that I have to check that. Maybe that it's not my translation. Yeah, but I can be something wrong when I put it on the slide. Gibbs, this is the other branch. That is just to see how you can model the world in different ways. Gibbs emphasizes, this is a quote. He's also talking about statistical mechanics. He has this very abstract, very formal models. And what he says? He said, here, there can be no mistake in regard to the agreement of hypothesis with the facts of nature, for nothing is assumed in that respect. I don't care. Logical consistency is the main aim. A model is good if it is logical, permissible, logical, correct. You recognize this is a very specific view of models. This is what we find in the axiomatization movements. The interaction with philosophy of science, you can see it directly. You have two approaches. The dominant approach is the semantic view of models. I could explain you that. The very dominant view of models. If you talk to a philosopher about models, that is what he means very often. The other is what I call, of lack of a name, it's the models that mediate account. That is the Morrison and Morgan. And Morgan is the same Mary Morgan, but she's also active as a philosopher, so that's another account. Okay. Semantic view. This model is an interpretation of the undefined terms of a theory that renders all the actions of the series simultaneously true. This is Aaron de Breu. This is Mick de Breu. But it's also Koopmans in the 3 essays on the state of knowledge. This is the way he talks about models. But if you have an axiomatization, if you have an axiom system, if you have a contradiction, you don't have a model. So that is why people are so keen on looking for inconsistencies, to check that, to go for, and this is the Hilbert program. This is the mathematical problem. You have heard about this, Hans? He gave this famous lecture which he defined all the mathematical problems that has to be solved. Now some of them are solved, and whenever they get solved, they get the newspapers. Right? Okay, so if contradicting attribute be assigned to a constant, I say the mathematical constant doesn't make sense. So consistency is all what we go for. That's the reason why also including economists, are so keen on consistency. And maybe you think that is really what we need, otherwise we don't have a model, but that is because of this program. Because you don't need it to build a model. Haha. The other branch is aiming, emphasizing appropriateness. So consistency is not what you need. Maybe you thought, but these are 2 Nobel Prize winners, Rachel and the last one was I have not updated it. Sorry. Whatever. Historical for the historical audience, it is so embarrassing. So, sorry. Granger. A theory. Okay, a theory means required to be internally consistent. Although consistency says nothing about relevance. It's like patrician. Jan Tinbergen also. You have 2 opinions. That's no problem. This is the degree which, and that's the way. This is an explanation. When he was at the League of Nations, he was developing what Kate later called Professor Tinbergen's methods. It was econometrics. The kind of econometrics he was developing is different from what Frisch's was. And he had to explain to people, the money givers, what he was doing. So he wrote memoranda. They are not published. They are in the archive of the League of Nations. And so to explain this, he used this. It is not about contradiction, now you have to combine it, even if they contradict each other, you have to find some way to balance, to bring this together. That is like Irving Fisher talked about these requirements. Irving Fisher was an inventor. He made a fortune of it and lost it. That's a well-known story. But he was, till the end, he kept on going, inventing. This is his last invention. We had a war. Why do we have a war, according to his? Because we didn't have the right picture of the world. It has to do with knowledge. So, maybe we should think differently about representing the world. So he was thinking about maps and globes. If you build a globe, the world is a globe, the earth is a globe, but the maps are two-dimensional. There's always a problem. You have to distort the representations. Ah, damn it. So if you have a map, there have always to be compromises. If you read it, that's the way he built this index numbers. That's the way he thought about representations. You can find it throughout his work. It's not only because related to maps, but also about models, representations. Mary Markham called Irving Fisher rightly the first model builder. I think she's right. Okay, now we have a few things about understanding, because that is what we aim at, don't we? How do we understand by models? We have these pictures. Yeah, we can understand the world by these pictures. This is the Marcel Boumans account. He said, if you, I just read it a lot, that's the best way to do. We do not learn much from looking at a model. We learn more from building the model and manipulating it. Just as one needs to use or observe the use of a hammer in order to really understand its function, similarly, models have to be used before they will give up their secrets. In this sense, they have the quality of a technology. The power of the model only becomes apparent in the context of its use. In our latest book, it will be published this year or the year after, this first chapter is still making this claim. We need to use it to get understanding. Is this original? No, there's a long history, starting with Galileo. Marcel is the historian who wrote a lot about Galileo. And he says something, that is the way, that is the method Galileo introduced to science. That has to do with making, producing, constructing it, is done. So in building the mechanism, because he didn't know, building the machines, Galileo, building it is getting understanding of it, not by looking at it, just creating it himself. This is a long history because Lord Kelvin, there's a famous quote in basic philosophy of science. It seems to me that the test is, do we or do we not understand a particular subject of physics is, can we make a mechanical model? And just read Lucas. In general, I believe that one who claims to understand the process of flight can reasonably be expected to be able to make a flying machine, and that understanding business science means the ability to make them do roughly the same sense. You see? That's a nice quote. Yes, I like it very much. So the last one slide, Boltzmann claiming the same thing. Understanding has to do with experience, with this object we try to understand. And that is what you also find in Galileo. That is a very long tradition about it. And that is what Morse and meant when we build a model. And you find it with the economics. What I try to tell you, understanding the history of modeling and the requirements of the epistemological and methodological history is a history you can only understand, but it also take account of the history of the philosophy of science or the history of science. But thinking about science is philosophy of science, or it's the history of philosophy of science. So interesting to what I have to hope to show you that for me to work with modeling, understanding this development of modeling, and I try to do this with also understanding geometric. Okay. Oh, yes. I knew this.
Hey, we have some comments and questions for Marcel.
Oh, that's terrific fun. I wonder whether when you write history of econometrics, it's useful to think about the parallel history of statistics. And that one of the things that we did in an earlier Summer Institute session, which then became a session at the joint statistical meetings, was ask how come there are codes of ethics in statistics but no codes of ethics in econometrics. You know, so that, and it's not like don't read each other journals or don't, it's. And another thing we could ask, we just haven't had the energy or time or whatever to look at the problem, is how come the robustness stuff caught on so much faster in statistics than in econometrics, and we can talk about how we know that's true. But I think I can defend that claim. And I think that if there's a difference between how econometricians self-defined and statisticians see the world, you might be able to shed light on what Chicago's doing, because the active ingredient in the middle Chicago period is people who are deeply influenced by statisticians. When Stigler reviewed Samuelson's Foundations, it was from Jepson. Samuelson calls Stigler a statistician in the first couple editions of the principles textbook. And we all know about Friedman and Wald and Savage and that sort of stuff. So that if there's there's a parallel history to statistics and econometrics, and then you've got this sort of Chicago group being heavily influenced by statisticians, not so much by econometricians, then there's a maybe there's a way of deepening our understanding of some of these debates that we've been looking at for a long time. But I think it's just obviously a terrific project.
No, it is. By the way, Mary came from the history of statistics. He was in Bielefeld, and it was about the probabilistic revolution. So but what we did for the Hope Conference is exactly what you were. But not only the history of statistics, but also you have to look at the history of engineering. You have to look at history. So what we invited people is to make this connection, because the original history, the 1980s histories, were very much written as if econometrics was a separate discipline, and that's not true. You see where the people come from. They have statistical backgrounds, they have engineering background, and we have to take account of it. So that is what I yes. Yeah, so you're right. That's,
excellent presentation. But you emphasize math and statistics and econometrics in your discussion. I'd like to make a plea for you to broaden your discussion, include geometrical diagrams and their development, because now we think of diagrams as just purely illustrative devices. But earlier generations of economists thought of them as analytical tools in which they derived theorems and results. And much of the history of price theory, international trade theory, welfare theory is it's got diagrams of its very DNA. And so I think, fortunately, there's a book coming out this fall by Blaug and Peter Lloyd called Famous Figures and Diagrams in Economics. And it's got 60 essays in it. And many of the essays, I would say most of them, the majority of them, trace the historical development of the diagrams and show how they helped further the development of economic analysis. So I think that
You mean Peter Howlett from the LSE?
Excuse me?
Is it Peter Howlett from the LSE? Oh.
I think I don't know where he's an older guy. I know he wrote a famous article on the development of production functions way back in the 1960s in the think it was in the, he's either in economic or JP, I can't remember, but he's not a really historian thought like Mark Loud is, but he's interested in the subject. And so the topic you're discussing is really in the air. Other scholars are working on it, but they're bringing diagrams as a tool to attack.
Well, again, that's great stuff. I'm looking forward to read it. That is certainly what I'm going to. No, that's not so much done on the history of graphs, and that's. I knew a few people that didn't know this one, so that's I'm looking forward. No, it's part of this history, so we have to take care of it. Yeah, of course. Yes.
Tom, do you have an article in there?
I do too.
What are they on?
I got one on Marshall and Cross diagrams, and the other on the Fisher diagram of intertemporal utility maximization.
You have to write down the reference.
Here it is. I've got it.
Okay, so that can I borrow? Get it? Okay, so that. Thank you.
Yes, may I? First, very interesting presentation. I got 2 comments, maybe to suggestion if you agree and you find usable. In my PhD thesis about Lange, I studied a 1932 article dealing with the French article Sur un problème d'économie pure. This article was part of our broader debate in the Zeitschrift für Nationalökonomie, Journal of Economics nowadays, and so I think that would be useful. This debate was about the destiny, the future of economic science. So I think it would be useful to check the whole debate since the beginning. The first number of the Zeitschrift, unfortunately, is in German, but I think the old we can go with it as in Dutch until 1935 at least. Then another comment about the historical background, maybe philosophical background. The reference of physics to physics is to me really fitting, it's correct. And I suggest to check Otto von Neurath manifesto of Circle of Vienna. In Italian is literally the Circle of Vienna and the future of logical empiricism, where it stresses that physics is par excellence the universal language of science, so that the influence on econometrics and economics is a wider adherence to influences of neo-positivism.
No, I just can comment on that. That's not a question, so I cannot answer, but I can comment. Is that I think that's some kind of, that's always what you see, this what we call the physics envy, and Miroski has written a lot about it. But that is not enough to have an understanding, because even in Miroski it's not always clear what kind of physics it's referring to. So if people mean that, I need to contextualize that because this is a standard view, and of course it is part of this history, because probably Frisch also thought about physics, but not sure because he had not a background in physics. But Tinbergen clearly did. But even in that period, it was not clear what physics was going into. You had this new development, of course, Einstein theory, well received in the Netherlands, but you had something like quantum mechanics. People had no clue what would direct. So you wouldn't use that as an exemplar or as a mirror for what you are. So whatever people say, and of course I can use it, but that's much more broader sense. But then, as an historian, we have to go deeper than go beyond that story. But that's exactly what they were referring to. But thank you for the Oscar.
If you want, I give you all the references.
I think I can look it up.
Okay.
I can find G-Store as the.
Oh yes.
Okay, my comment is directly connected with this comment. He mentioned Otto Neurath and the Manifesto of the Inner Circle, and I would like to mention that in that period, Otto Neurath and Frisch, there was a long correspondence between them, because Otto Neurath was trying to write this encyclopedia of unified science, and when he thought about the role, the place of economic theory in something about your new economic theory and the application of statistical data to economic theory, because I don't like very much the economic theory of my friend Carmen Jr. that is applying the formal mathematization into the economic theory. I don't like it very much because it's too abstract. It's not very concrete. It has nothing to do with the concrete data. And I like very much your model. So please join us, join your project at Frisch, of course, refused. But there is a...
Yeah, no, there's a lot of things
yes.
Albert Joling has written about this. In fact, it came to Jan Tinberg because Otto Neurath was in The Hague.
Yeah.
And so he got Jan Tinberg involved in this project, and it also failed.
Yeah.
Because even Tinberg, and they didn't do what he liked people to do. So but it had also so influence, and that comes back to graphs. Otto Neurath has this idea of this pictures and that kind of thing, and that has to influence. You see publication that CBS, the Statistical Bureau in the Netherlands, using Otto Neurath kind of pictures. So that's
He's a type, yes.
Sorry?
He's a type.
Yeah, exactly, of course, yes. But you see, so there's a very nice history about it, and that connects to it has to do how do we represent statistics. You can draw a line, but maybe there's another way of doing it. And so this is very nice, and it even has a longer tail than...
This is exactly because Neurath was interested in econometrics and in statistics in general, because he was accustomed to use this isotype in order to explain economics and social development inside Vienna during the period.
Yeah, the example in the CBS is alcohol misuse.
Yeah.
And so you need you want to show that something is wrong with drinking too much alcohol. So you have to, the audience is different than the academic audience, and so you get a very nice booklet out of that. Yes, that's true.
Thank you. Two minor comments. First, the problem with rational reconstruction being normative. In your reformulation, the slide that says critique, you were still talking about writing D-history. So I was wondering, is this on purpose or should it be writing A history? And then probably the last, but I'm just to make sure. And secondly, so I would fully agree with you that that you need both philosophy of science and history of science. But in the rest of your talk, it also becomes clear that you very much favor one type of philosophy of science as opposed to the other. And at first I thought you meant something like using one and keeping the other constant, or I was wondering whether you could say a little bit more about...
I'm not favoring any philosophy of science. That is not what I want to do. I only show if you have a different philosophy, it leads to different kind of models, and that way it influences the practice of, for example, econometrics.
But I thought you would say that the semantic view of models you disagree with, whereas the other...
No, that's the dominant one. That is what you will find.
So it's simply pure descriptive, showing which...
Yes. No, no. Otherwise, I would take the old-fashioned stance and say what's the right way of doing things in an indirect way, and that is not what I want. I want to understand.
Yeah, but you can also say this is the right way of understanding it, or this is what I think is the proper way of understanding it. But that's not.
No, that's not what I want.
Thank you. There's a lot to think about here. So to the second part of the talk, I kept thinking, what is the difference between a model and a theorem? And I understand a theorem, and in a sense, when you talk of the model, and then the model's full potential emerging through the use of the models and so on, it's all very fascinating. So in a sense, you are giving it much more body than a theorem. So in a sense, to de Broglie, the Arrow-de Broglie model is really encapsulated in theorems. And so as I kept on thinking through your talk, then if you allow me to continue with this difference between, or trying to get a grip on theorem versus a model, and then feeling inadequate about understanding a model, but feeling somewhat more adequate about understanding a theorem, then I say, then the question is a theorem, when it deals with economic phenomena, by necessity includes and excludes. So then I see these Boltzmann criteria, and then I say, okay, so then what are these criteria for inclusion and exclusion? So what is the appropriate inclusion and appropriate exclusion? And then you get the second and third order. So I'm just telling you which I mean, in a sense, all of this is stimulated by your talk. Yeah. And so then it goes back into the thing that it is, and I think Roberto already brought out that the physics is the right way, and so in a sense very nice orthogonality to your point of view. Political theorists have been struggling, like economic theorists, how to write political, the theory of politics. I mean, in that sense, there's the Cambridge School with Skinner and Dunn and Pocock and so on. And there is in some sense, when I think of exclusion, your talk at least excludes that register. So I'm just telling you where. That's why I'm very keenly looking forward to reading the paper.
Just to start with the last thing, of course, this book meant provocative to say the history of economics as the history of tools and techniques, and of course it is excluding a lot of developments. But it is taking over what Robert Lucas did in his article. He does the same trick. What's the economics all about? That's technical developments. And okay, so it's not about that whether you agree or not, but just take that just for a while serious and try to understand what the context of this article is. So I'm not saying I agree or disagree, but just understand what is the context, where does it come from, what is the tradition where he can write these things. And so the history is very much based in the history of the influence of computers. And if you see that connection, that is what I try to have done, is that you see why he can say such a thing, and why he thinks and he's serious about it. You see, okay, any philosophy, any branch you take is inclusion and exclusion. Just about this is not taking models really serious. This is saying, this semantic approach and saying that it's all about theory. That is what you say. It's all about the axioms. If you have the axioms, then you're done. So the other branch in the tree is more a pragmatic branch. We have questions and I want to solve them. And we use anything what we need. You see, so then, of course, the one excludes, both excludes and includes.
You know that slide when you used to show the influence of physicists on timber, and you got two branches.
Yeah.
The last one, J. Willard Gibbs, you could draw another arrow and link him to Irving Fisher. Exactly. He was Fisher's teacher at Yale. And you started out with Fisher's dissertation. And you know, Fisher, before he wrote that dissertation, he was talking to William Graham Sumner. And he said, I don't know what to write about. I'm interested in economics, but I'm also interested in physics and mathematics too. And Graham Sumner said, well, you know, why don't you write on mathematical economics? And he said, I've never heard of mathematical economics before. But he kind of used Gibbs' techniques. So Gibbs really did influence Fisher, so you could draw another
but still I refuse to do that. Okay. I know that he took some of the things to go from him. One of the first papers Gibbs wrote is about visualization. So that's interesting for your project. So that's very much, we have physical knowledge, and so he uses graphs and all kind of things, pictures, to so that is why urban fishing get it from, because in the thesis you also have these, in the later edition you have these pictures of these machines, so that is what he got. But the difference is, and that is the reason I don't put them here, is that for kids they were only illustrations.
Oh, I see. Okay.
But Fisher was much more serious. They gave knowledge.
Yes, yes.
And that's so. If I would put Urban Fisher somewhere, he belongs here.
Okay, okay.
So that's the reason I.
Another thing, I don't know if you quoted this, but there's that great quote from Gibbs that was kind of corresponds to what the fellow said up there. Gibbs, mathematics is a language.
Yeah. Yes, he looked different. So what you don't see in Gibbs' work is something what looks a little bit like modeling. You won't find it because he was very explicit. That is not the way to do it. You see, so therefore you have the modeling practice in the way of course you have here the experimental approach comes from this, the break comes from this, so that is what you get here. Okay. Highly abstract systems in which models have only a very small role to play. It is all about the actions or the theory or the theorems.
Yeah, thank you. You really taught me something. I thought that I didn't really understand the relation between Gibbs and Fisher.
Okay.
Thank you.
I realize you said you were doing a history rather than the history, but I'd like to go back for a minute as you sort of elevated epistemology and put away ontology. And it was fun, so the last slide just before that, you had up there had David Hilbert, and don't have to put it back, but I remember seeing that just now. David Hilbert reminded me that probably 40 years ago or so, Oscar Morgenstern had a paper out that he started off by quoting Hilbert in that kind of sense of unsettled problems, and Morgenstern was doing some unsettled problems. And thinking of that kind of piece makes you think that you have this two-branch thing. And Morgenstern, I think, you might remember that article that had a third branch, which is that it was getting to the ontology in the sense of saying that social systems weren't sort of analogous to physical systems, but there was something about the, I think, social systems that had kind of an open-ended kind of quality to them. And which may be going backwards, and historically you get multiple equilibria going forward in that kind of, going forward ontologically, what you get is an open-ended history, whereas we sit here today, there isn't one place we're going, but there are many possible places we're going, and how to model that. That perhaps gets into complexity kinds of ideas, agent-based modeling ideas, and that.
Now, you're quite right pointing on the weak that made more branches. Morgenstern is one I'm really struggling with at the moment, I can tell you. The other one is Leonchev. It's also hard to put in these too simplistic. So Leonchev and Morgenstern, they of course they're different, but they seem to do something else than this one, and I don't have a grip on that. And if I would, then I can tell you more about it. But that's yes. Thank you for this.
Are there other questions, comments? This has been a really good day and a great